My name is Valentin Bartenev. I'm a developer at nginx company. And today I'm going to talk about disadvantages of HTTP2. It's in contrast to many talks and articles you can find in the internet, because you may see a lot of articles that make focus on benefits, praising the HTTP2 protocol like it has no disadvantages at all. But these articles usually present HTTP2 as an absolute replacement for HTTP version 1. And such position actually can mislead you and encourage to take a wrong choice. So the truth is that HTTP2 was designed in the shortest terms with a certain goal. And unfortunately, this protocol is far from being ideal. It has limited use case and many drawbacks. And I'm going to talk today only about drawbacks. First of all, HTTP2 introduces a huge layering violation. It's an application level protocol that works over TCP, but at the same time it provides another transport layer. Moreover, HTTP2 has similar features like TCP. It has flow control, it has packet layering, and multiplexing. So, in fact, it duplicates most of TCP functionality on the wrong level. And multiplexing is usually introduced as the main technical advantage of HTTP2. It's very simple. You can split the data into small packets and supply each packet with a header that identifies the request that data belongs to. Thereby, you can mix data from different requests or responses over one TCP connection. So actually exactly the same happens on the TCP IP level when you use multiple HTTP version 1 connections. So each TCP IP packet can be identified by source and destination addresses and ports. So, but multiplexing on the TCP level has a number of advantages over multiplexing using HTTP2. First of all, it works in the kernel space. So it's quite efficient, and actually you can use your resources more efficiently, because different connections can be handled by different processes of your application. Also, what makes HTTP version way more scalable, HTTP version 1 more scalable, it's because different requests actually can be load balanced on different hosts or even different physical channels, which isn't possible with single HTTP2 connection. Due to its own multiplexing, HTTP2 also needs its own implementation of flow control and prioritization. When you have only one channel, you should carefully decide what data you need to send next. So it requires also different amount of control information. In each HTTP2 endpoint has to continuously notify how much and what data it's ready to receive. And such additional communication between endpoints not only increases transmission overhead, but also can lead to various delays. And inefficient implementations of flow control can actually reduce throughput very notably. And so-called head-of-line blocking also is more dangerous in case of HTTP2, because it delays all requests in one connection, in one HTTP2 connection. While if you have head of line blocking on HTTP1 connection, you delay only one request. And a number of HTTP2 problems also related to overcomplicated prioritization. It's represented by a complex tree with weights and inheritance. The client can do various operations over the tree and by sending special commands. And the HTTP2 specification unfortunately describes how prioritization is represented, but it doesn't describe how it should be used by clients and doesn't specify any limitations. So as a result, each browser implements prioritization its own way, and nginx has to be smart enough to support it the best possible way. Also many articles claim that HTTP2 is faster and more efficient because it's binary, and it's not quite true. Authors of these articles actually overlook the fact that HTTP2 uses the same semantics, and you have to parse header fields the same way as in HTTP1 because they are still represented as ASCII text. For example, you have to parse the content length header and its number out of ASCII bytes. So it's the same in both protocols. And yes, HTTP2 has header compression, and it can save you a few bytes on transferring, but at the same time, you barely notice it comparing to amount of data sent with body. And with additional overhead that adds these control structures. And generally, even idle HTTP2 connection can actually require some more memory than HTTP version 1 because you have to keep states for compression, you have to keep states for prioritization tree, and because it's due to the fact that in HTTP2 compression is stateful, so you have to decompress each request even if it's not needed for you. And you have to keep the compression state when you have no requests in connection at all. And the most frustrating here is that HTTP2 is symmetric in terms of resources. Browsers have to deal with only a few dozens connections, while servers have to deal with thousands or maybe millions of clients. So equal requirements to client and to server multiplied by highly unequal number of connections, it's very inefficient, I think. So multiplexing, flow control, and prioritization, headers compression, and binary representation add a lot of complexity to the protocol. It's hard to implement, and it's hard to debug. And HTTP version 1 you can read just like a book, and you can do that with HTTP2 without special tools. Even with such tools, you actually may not spot the problem because of complex logic of the protocol. So in addition, very complex protocols that focused on requesting many resources in parallel is a huge vector for DOS attacks. And summing up, actually, I want to draw your attention again for the fact that HTTP2 is a single-purpose protocol. Its main purpose is optimizing page loading times and reducing delays between browsers and web servers in the internet. So the benefits of HTTP2 are achieved by overcoming specific limitations of this scenario. So I just named 3 of such limitations. It's no already established connections between client and server. Number of parallel connections is quite limited, and establishing a new connection requires significant amount of time. So it's a perfect case for browsers which are limited usually by 6 connections to the host. And it's also disappointing that authors of HTTP2 specification actually were so concentrated on solving specific use case and ignored all other problems that presented in HTTP. So I think you shouldn't consider HTTP2 as a mandatory replacement for HTTP version 1. And HTTP2 actually can suit your use case or cannot. It depends on your limitations and on your purpose of how to use it. For example, I think HTTP2 between nginx and Upstream servers is meaningless because you can use more. In this case, nginx doesn't limit it by connection numbers, and also you can use keep alive pool of connections, and you don't have to spend time on established connection for each request. So I think that's all. Thank you. And if you have any questions, you can ask me here. I think we have some time, or find me on the nginx boss. As I know, reprioritization isn't used by any browser now, but and I think it's currently it's not configurable, and it's not used at all. It's just a concept in the specification. At least I never seen that any browser reprioritizes any connection in flight. So usually Firefox just pre-establish prioritization tree and then just attach any request to this tree and doesn't change any priorities in flight. And Chrome does something similar.
Hello, it's on. I have a microphone right here if you want to talk to it so everyone can hear your question.
What do you think about the mandatory encryption in HTTP2 that is effectively mandated by all the browsers?
Can you repeat the question? I'm sorry.
Oh, so most of the browser vendors, they only implemented HTTP2 with mandatory encryption. Although the protocol says that it can be supported with or without encryption, almost all of the browsers, they implemented it only with encryption. What do you think about that?
I think it's because because TLS handshake requires additional time, and HTTP2 benefits mostly from saving handshake time and handshake latency. So I think it's just not very beneficial for HTTP2 to be used on a pure TCP. And HTTP version 1 works with pure TCP pretty well.
This is a bit off topic. Just does nginx has any plan to implement UDP-based transport like Quick?
Yeah, I don't know about any exact time when we are going to implement it, but we asked about it a lot of times, and I think eventually we are going to implement it anyway. It depends on how maybe popular Quick will be eventually, because even now, as I know by various statistics, HTTP2 used only by a few percent of web servers in the internet. And implementing Quick actually will take a lot of time and take a lot of work. So we have to decide carefully there, because actually we already spent a lot of time on implementing Speedy version 2, then Speedy version 3.1, and eventually these protocols were just dropped by Google. And we don't know what the future of Quick right now. So we have to be careful here to not spend a lot of time on protocols that is going to be just experiment and will be eventually dropped or changed by or replaced by something else.
Do you think there's any benefit to implementing HTTP2 for upstream proxying? So sending HTTP2 requests to like an upstream application server?
There are a number of problems with HTTP2 on upstream proxying, because I think prioritization and flow control mechanisms just are not very scalable, and you eventually need to use multiple HTTP2 connections to backend server, at least if you have a number of processes on this server, and you don't want all requests handled by only one process. So it's actually a very complex task, and I'm not sure about any benefit here. So
when HTTP, how to do the 7-layer load balance?
How to load balance HTTP2?
7-layer load balance, maybe URI load balance. When we use HTTP2, how to do the 7-layer load balance?
No, actually, I can understand the question. Maybe you will ask me about ask me after this talk personally. Or can you describe it?
If we use HTTP 1.1, we can do the load balance by URI or something. If we use HTTP 2, how do I do the load balance by URI?
Well, if you use HTTP2 and want to load balance it, you have to, if you want to load balance it by URI or anything else that presented in the headers, you have to parse the full protocol and then load balance it, and then repack it to different HTTP2 connections. So you have to unpack it and repack it back anyway. And you can't just load balancing by pass through all HTTP2 frames or all data. You have to parse it and implement the server layer and a client layer and something that will load balance between these layers. So it's pretty inefficient.
Any more questions? Yep. Way over there.
So you just covered the disadvantages of HTTP2, right? I mean, if there are these many disadvantages, why in the first place? What do you think? Like, why in the first place they invent or they just got the protocol of HTTP2 into the market? What do you think about it? And are there any use case that you can think of moving to HTTP2 from 1.1 or HTTP1 moving to HTTP2? Are there any use case you can think of? If there are no use cases, why people thought about bringing HTTP2 with these disadvantages? Are they worried about speedy being popular or something like that? What do you think from your perspective?
You actually, if you understood the question right, you're asking me about what the best use cases of moving from HTTP1 to HTTP2, or?
One of the use cases that you can think of, and if there are these many disadvantages in the protocol, why did people bring that into community? Like, why did people develop HTTP2 protocol?
Well, because I named one use case, and it's use case very popular. It's about communicating between browser and web server with a large number of resources and over encrypted connection, and it's the main purpose of the protocol, and the main purpose is to reduce page loading times, and it works well. But I just concentrate on the disadvantages in this talk because it becoming so popular and people started to use it everywhere, even for use cases that HTTP2 isn't designed for. So I think the most common use case for HTTP2 is a website that has a lot of resources, a lot of images, styles, and scripts, and you want to use encryption, and you don't want to suffer on big delays while establishing many TLS connections and so on. So it works well because typical browser is limited by a number of connections to the hosts, and because it saves time for establishing TLS connections.
We have one more question.
Excuse me, sir. Real quick. I was hoping if you could talk from one of the use cases of HTTP2 is the ability to do push from the server side. And I was curious if you had any known disadvantages about doing that.
I think it should be decided carefully. I've seen many reports that in some cases server push can reduce page loading times. In some cases it can actually increase them because you eventually will push resources that browser already have. So it's a quite complicated scenario, and nginx currently doesn't support server push, but we receive a lot of requests about it, and maybe eventually we will implement it, but it should be used with care, and you should test your use case if it works for you or not.
I'll meet you halfway.
By the way, we already ran out of the time, so I think it should be the last question.
So when we have a communication between nginx, so let's say you have the client sending request to nginx, then nginx forwards the request to another nginx. It goes through a number of nginx. So do you recommend enabling HTTP 1.2 for the internal communication between the nginx, or you don't recommend?
Can you repeat or describe the question?
What are your recommendations for the communication between the two nginx? Are we supposed to enable 1.2 for the performance reason, or do we
Okay. So I think HTTP stack in nginx is actually pretty good. So you can use just proxy pass directive and use plain HTTP. And if you have big latencies between your front-end and back-end servers, you have to keep alive connection pool. And I even don't recommend using HTTPS, and in this case, because if you need encryption between your front-end and back-end, it's better to implement some encrypted channel like VPN, or that will be already established and that will be just used transparently by nginx. So my recommendation is just use plain HTTP version 1. And with keep alive connection pool if you need it. So thank you everyone, and if you have additional questions, you can find me on nginx boss.